Greetings and welcome to STEM Smart Academy. We are going to discuss the Maranda High School mock examination, June 2026, Mathematics Paper 1, Section 2. Before we start, our consultation number is 07 41 30 43 and 11. You can call or WhatsApp that number, then our team will be able to respond to you. We finished discussing the section 1 part of this paper, so straight away we are going to have a look at section 2. Let's go to section 2. In case you missed this section 1, the video is still there in our channel. You can cross-check and have a look. Section 2 says, Miss Linda filled a cuboid wooden box of length 45 centimeters, width 15 centimeters and height 27 centimeters with 675 spherical plastic containers without deforming them so that no more container could fit. Calculate to 2 decimal places there. Part A, the maximum radius of each spherical plastic container in the box. So here we need to be very understanding. Here we need to be very keen. For the length of 40, if I assume my spherical container has a diameter of D, then if I want to get the number of spherical plastic containers, I'll take, when I take 45, which is the length, over the diameter D, I'll get the number of spherical containers that will fill along the length, the wooden box lengthwise, multiplied by, when I take 15, which is the width, over the diameter of the sphere D, I'll be able to see the number of spherical containers that will be filled going towards the width side times 27 again over D. This will give me the maximum number of containers that are of spherical plastic containers that will be filled going upwards. This one here, should give you a total of 675 spherical containers, because that is the total number. So when you execute this, so this will be 18,225 all over D cubed should be equal to 675. So this means that D cubed will be equal to 18,225 over 675. So meaning that our D cubed in this case, dear learners, is going to give you 27. Now to get the diameter of the one sphere, you're going to get the cube root of 27, and the cube root of 27 evaluates to 3. So the diameter is 3, but now they want the maximum radius of each spherical container. So now to compute the radius, we are going to divide the diameter 3 by 2. So this gives you a radius of 1.5 centimeters. 1.5 centimeters. Part B, the mass in kilograms of the cotton required to fill the empty spaces, given that the density of the cotton is 550 kilogram per cubic meter. So in this case, let us first get the volume of the box. Volume of the box. Volume of the box, which will be given by the length 45 times the width 15 times the height 27. This evaluates to 18,225 cubic centimeters, which we can convert to cubic meters by dividing by 1 million. So when you have this 18,225 you can divide this by this. So this moves a decimal point here, this moves 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 here. So you get your answer is 0.018225 cubic meters, because 1 cubic meter is equals to a million cubic centimeters. So once we have this is the volume of the box. Let us calculate also the volume of 675 spheres. Volume of 675 spheres. It will be given by 675 times the volume of one sphere, which is usually 4/3 pi r cubed. So this will be 675 times now 4/3 times pi, which is 22/7, times the radius, which is 1.5 cubed. So when you execute this, you're going to get this as 675 times 4/3 times 22/7 times 1.5 cubed. This becomes 9546 Have I done this multiplication well? Let me cross check again. Let me have my calculator reset for high accuracy. I repeat that process. Mm-hmm. 9546.428571 cubic centimeters. So the moment I have this, we can get the difference between the two. How do we get the difference in the volumes? Because if this is the volume occupied by it, in fact I can convert it first. Maybe even before I convert, I can just do the subtractioning. Let's get the empty volume. To compute the empty volume, I'll take the volume of the box in cubic centimeters was 18,225 minus the volume of the 675 squares, which is 9,456.428571. When you subtract this, let us do this subtraction. You get 86 78.571429 cubic centimeters. Because now that is in cubic centimeters, we can convert it to cubic meters by dividing also by 1 million. So when you have 8678.571429, divide this by a million, what will it be? This one moves a decimal point here, this one moves it here, this one moves it here, this one moves it here, this moves it here, this moves it here. So you get your volume as 0.008678571429 cubic meters. So now the moment we have that, now we want to compute the mass. How do we compute the mass, dear learners? Mass is usually given, because you know that density is equals to mass over volume. So mass is density multiplied by the volume. So the density here is 550 multiplied by 0.008678 571429. So when you execute this, you are going to get a volume of I'm getting let me see, just a minute, let me compute it. When I multiply this by 550, I'm getting 4.7732 kilograms. Have they restricted us on the number of decimal points? No. So that is the mass. Part C, the radius in centimeters of the cylindrical container of length 1 whole number 1/3 meters, which can be filled with the liquid from the 675 spherical containers packed in the wooden box above. So first of all, we had the volume of the we know that they want the radius in centimeters of the cylindrical container of this length, which can be filled with the liquid from the 675 containers. So what we should know here is that the total volume of the liquid, the total volume of the liquid is equivalent to the volume of the 675 spheres, or the 675 spherical spheres, which in centimeters we had as 9546.428571 cubic centimeters. So considering this, the length of the cylinder, we've been told that the length of the cylinder is 1 1/3 meters, which is 133.33 centimeters. So let us apply the formula for getting volume of the cylinder. Volume of the cylinder should be given by the formula pi r squared h. So our pi in this case is 22/7 times the radius. We now need to multiply this by the radius, which we don't have. We can say by r squared, then by the height, which is our length in this case, 133.33. So this expression here should give you the volume of the cylinder. So after getting this, because we know that the volume of the liquid should be equal to this volume, so 22, when I take 22/7 times 133.33, this is giving us 419.037 r squared. This volume of the cylinder should be equal to the volume of the 675 spheres, which is 9546.48, sorry, 0.428571. So r squared here will be given by 9546.428571. Divide this by 419.037. So the value for r squared will be, when you take 9546.428571, divide this by 419.037, you'll get 22.782. Then the radius will be the square root of 22.782. So when you square root 22.782, you're going to get 4.77 as the radius. 4.77 as the radius. That's how you solve that question. Let's go to question number 18. The gradient of the curve y is equal to ax cubed plus x squared plus 8x plus 2 when x is equal to 2 is negative 3. Part A of the question, determine the value of a. So you've been given the gradient and you have the equation of the curve. Let's get the gradient function, our dy dx. So we'll say that dy dx here will be equal to, when you're differentiating, you drop the power down, then you raise the power by 1 to get the new power. So this is going to give us 3x squared, 3ax squared plus 2x plus 8. That is our gradient function. Now to get the gradient, we usually substitute the value of x to the gradient we literally substitute the value of x to the gradient function. So our gradient will be given by now 3a into x. Our x is 2, so into 2 squared plus 2 into 2 plus 8. Remember our gradient here is negative 3, so negative 3 is equal to, this will be 12a plus 4 plus 8. So this will be now 12 when it goes there. Negative 3 minus 12, this is negative 15, is equals to 12a. So what is the value of a? A in this case will be given by negative 15 over 12. When you have negative 15 over 12, I hope I'm doing it the right way. Let me confirm again. 3x squared plus 2x plus 8 is equal to, when x is 2, so this is 4, 12, 4. All right, let us see. So the value of a here is 1.25. A is 1.25. The value of a is negative 1.25. Because you see now our a is negative 1.25. Let us make some progress. After we've gotten the value of a, we can now go and work out Roman 2. The equation of the tangent to the curve at that point in the form of y is equal to mx plus c. So because we have now the value of a, we can now get the equation of the curve. We know now that the equation of the curve y will be given by ax cubed. Our a is negative 1.25. So we have here negative 1.25 x cubed plus x squared. So this is plus x squared plus 8x plus 2 plus 8x plus 2. This is the equation of our curve. They are saying at that particular point. So let's see, when x is 2, what is the corresponding value of y? Because here the value of x is 2. So we can say when x is equals to 2, comma, then y will be given by negative 1.25 into 2 cubed plus 2 squared plus 8 into 2 plus 2. So this will be negative 1.25 multiplied by 2 cubed, which is 8. You get this as negative 10 plus 4 plus 16 plus 2. So this will become, when you evaluate this, you get this as 12. The y value is 12. So that point is 2, comma, that particular point is 2, comma 12. I hope you've understood up to that particular point. Now, after we've known this particular value, after we've known this particular value, the point is 2, comma 12. Now they want the equation of the tangent. To get the equation of the tangent, it's very simple. What are we going to do? We have the point and we have the gradient. Now we are going to say y minus 12 all over x minus 2 should give you the gradient, which is negative 3. When you cross multiply, you'll have y minus 12 is equal to negative 3 into x minus 2. Let us open these brackets. Let us open the brackets. So this will be y minus 12 being equal to negative 3x plus 6. Then you collect the like terms. You'll have y is equal to negative 3x plus 6 plus 12. So y is equal to negative 3x plus 18. So that is the equation. Y is equal to negative 3x plus 18. You are done with that case. State the coordinates of the turning point of the curve. Y is equal to 2x squared minus 4x plus 3. Hence determine its nature. So what we are going to do here, when I have the equation y is equal to 2x squared minus 4x plus 3, what I'll do, I want to get my dy dx here. My dy dx will be 4x minus 4. That is my first derivative. Now remember, they want the coordinates of the turning points. What do we need to know here? At a turning point, you should know that dy dx is usually equivalent to 0. So I'll take the expression for dy dx, which is 4x minus 4 equated to 0. This will mean that 4x is equals to 4. Therefore, the value of x will be equal to 1. Once I've gotten the value of x as 1, I can now go to the corresponding value of y. I'll say when x is equals to 1, when x is equals to 1, when x is equal to 1, then y will be obtained by substituting x to the original equation. So the original equation here is 2 into x squared, so 2 into 1 squared minus 4 into 1 plus 3. So this is like saying 2 minus 4 plus 3, which is 1. So the y value is 1. So our turning point is 1, 1. That's the coordinate of our turning point. So the moment we have this, now we can give the sketch. To get the nature, I'll have here the x value, the gradient, and the diagram. I'll use two methods to illustrate it. So when x is 1, to the left it's 0, to the right it's 2. What is the gradient? You replace this with the gradient function. So when x is 0, the gradient will be given by 4 into 0 minus 4, which is negative 4. So this is a negative gradient, it drops that way. When x is 1, it will be 4 into 1 minus 4, which is 0. So because the gradient is 0, meaning it's stationary. When x is 2, 4 into 2 minus 4, that is 8 minus 4, which is positive 4. So the positive gradient is that way. So you can see from negative through 0 to positive, that makes this point to be a maximum point, sorry, a minimum point. We are now going to say the point 1, 1 is a minimum point. Or let me show you method 2 of evaluating the same. With method 2, because I had my first derivative, the dy dx being equal to 4x minus 4, I can now say the second derivative d squared y over dx squared being equal to, when you differentiate this further, you will get 4. Once you differentiate that, now with the second derivative, what happens? You've now to compare this to 0. So you can see that this second derivative has given you a value which is greater than 0. So we can say here, since 4 is greater than 0, then the point 1, 1 is a minimum point. If the point is greater than 0, the second derivative gives you a value that is greater than 0, that point becomes a minimum point, otherwise it would have been a maximum point. I hope that one has been well understood. Let us look at question number 17. So that we can visualize it and agree exactly on what has to be done. So not 17, but question number 19. We are getting to question number 19. I think we are progressing very well. Don't forget subscribing, liking, and sharing these videos with your other friends so that they can also benefit from what we offer from STEM Smart Academy. So the question is, James may either walk to work along a route 5 kilometers or take a bus journey of 7 kilometers. The average speed of the bus is 24 kilometers faster than his speed while walking. Taking the average speed while walking as x kilometers per hour, write down an expression for the time of journey when walking. How do you get time? Time is distance over speed. So when you are walking, this person will use a distance of 5, will cover a distance of 5 kilometers, divide by a speed. The speed of walking is x. So the expression there becomes 5 over x. Part B. So Roman 2, the expression of the time when traveling by bus. When they travel by bus, the distance covered is 7 kilometers over the speed. We are being told here that the speed of the bus is 24 kilometers faster than that while walking. So if the speed of walking is x, then by bus it will be x plus 24. That is how you get the 2 marks there. Part B, given that the journey by bus takes 36 minutes less than the journey on foot, calculate the speed of the bus. So when you are told that the journey by bus is 36 minutes less than that of the foot, meaning when you take the time taken while walking on foot, which is given by 5 over x, minus the time taken while walking by bus, while traveling by bus, which is 7 over x plus 24. Because these expressions, each value is in hours, this should be equal to 36 minutes, which when converted to hours is like saying 36/60. That is how you form an expression. Then, to solve this expression, we are going to have that expression as 5/x minus 7/x plus 24 being equal to 36/60. I'll multiply through by the LCM of the denominators. The LCM of the denominators here are x into x plus 24 into 60. Also here we have x into x plus 24 into 60. Also here we'll have 60 into x squared plus 24x. So when we reach at that particular level, ladies and gentlemen, let us now evaluate it. After multiplying through by the LCM here, x and x will cancel. So 60 times x, this will be 60x. Let me have here 5 into 60x plus 24 multiplied by 60. You get this as 1440 minus, in this case here, we'll see that x plus 24 and x plus 24 will cancel. So this will be 7 into 60x being equal to, here 60 and 60 will cancel. So this will be 36 into x squared plus 24x. Let's open the brackets. This will be 300x plus 1440 multiplied by 5. You get 7200 minus 420x is equal to 36x squared plus, when you take 36 you multiply by 24, you get 864x. I want to write this as a quadratic, or let me maybe, yes, as a quadratic. This will become 36x squared plus 864x plus 420x minus 300x minus 7200 is equals to 0. So this will become 36x squared. Then I have 864 plus 420 minus 300. This is 984. So this is a positive, plus 984x minus 7200 is equals to 0. So when we reach at this particular case, we've reached at this particular case, what are we going to do? Let us see how we are going to reduce this. When you divide, let me try dividing this by 36 and see times 36. So this one I'm going to divide through by 12. When I divide through by 12, this will be 3x squared plus 82x minus 7200 divided by 12. This is 600. Should be equal to 0. So when we are in this case, we can solve out this using the quadratic formula. I want to solve it using the quadratic formula. Remember, when you have this, it means our a value here is equals to 3, our b value is equals to 82, and our c value is equals to negative 600. So with the quadratic formula, ladies and gentlemen, we know it is given by the formula x is equals to minus b plus or minus the root of b squared minus 4ac over 2a. That is the value we have. So that is the formula. So let us apply the formula to solve that particular part. So the moment we found this, we have this formula. Now we are going to substitute. When you're doing your substitution, remember that our value of b is 82. So this is going to be minus 82 here, minus 82. Then plus or minus the root of b squared. What is our b? Down here we've already written our b as 82. So this is the root of 82 squared minus open brackets 4 times AC. Our A is 3, then our C is negative 600. So 3, multiply this by negative 600. Whatever that is inside the root, we also call it the discriminant. So you need to be very familiar when you meet such a question in an exam. So this is 2 over 2 times 3. So when you solve this case, what are we going to get? So this will be minus 82. We have here minus 82 plus or minus the root of, let's solve what is inside the root. So I'll have here 4 times 3 times negative 600. This is negative 7200. Then 82 squared, you less that. Then you square root it. You're going to get 118. So this is 118 over 6. So here we are going to get two values of x. Our x, the first value of x will be obtained by taking negative 82 minus 118. Then you divide this by 6. This gives you, when you sort this, remember our x should be the speed. So this gives you, when you take negative 82 minus 118, we are lessing 118, then we are dividing this by 6. This gives you negative 33 and a third, negative 33 and a third, or in the next case is when you take negative 82 plus 118. I'm also computing from my end, then you divide by 6, you get 6. But because x was the speed while walking, we are going to ignore the negative one. Therefore, we are going to conclude by saying that x in this case is 6 kilometers per hour. X in this case is 6 kilometers per hour. So this is 6 kilometers per hour. What was the question asking once again? The question was asking, calculate the speed of the bus. They want the speed of the bus. Remember, x was the speed while walking. But they said the speed of the bus is 24 kilometers faster than that while walking. So the bus speed, we are going now to say that the bus speed here will be obtained by taking 6 plus 24, giving you 30 kilometers per hour. A very, very good question. So after we've gotten that as 30 kilometers per hour, ladies and gentlemen, we can now proceed to part C of this particular question, where we are being told that on a particular day, he delayed by 5 minutes before setting up for the journey to work by foot. Calculate the exact speed in kilometers per hour he walked to reach the place of work at the usual time. Remember, if this person has to go to work by foot, the distance he has to cover is 5 kilometers. Walking on foot, this person opted to use the 5-kilometer route. Now they want the speed. For you to get speed, you must have time. Now, dear learners, this is where I want us to be very, very keen and very, very observant, more so with the issues concerning the time. What are we going to do in that particular case? What are we going to do in that particular case? What we should do in that particular case is very simple. What we should do in that particular case is very simple. So we need to get the time, then from it we'll see. Remember, let's get the usual time taken while walking. Usual time taken, let's come back here and have a look. The time taken while walking is given by 5 over x. Usual time taken is usually given by distance over speed. The distance is 5 kilometers. Divide by the speed. While walking, the speed is x kilometers, so you divide this 5 over 6. So when you divide this by 5 over 6, when you divide 5 by 6, this is 5 over 6 hours, which when you multiply by 60 to convert it to minutes, this is like saying 50 minutes. What do you learn in this case? When this person opts to walk to school or on foot, he takes 50 minutes to reach to school. But on this particular day, he delayed by 5 minutes. Remember, the aim is to reach to school within the 50 minutes. But if you delay by 5 minutes, meaning now the time taken in this case now, this person has to use the remaining 45 minutes. You take 50, then you less this time, 5. This means you'll be left with 45 minutes. This person has to use 45 minutes to reach to school. And if the person has to use 45 minutes to reach to school, then this will again tell you, in this particular case, that because the distance is constant and the time has reduced, therefore the speed ought to increase. So now to compute the speed, ladies and gentlemen, once again, speed will be given by distance divided by time. My distance here is still 5 kilometers. I'll divide this by the time, 45 minutes. 45 minutes in terms of hours will be 45 over 60. Then you can now use your calculator to compute that one very fast. 5 divided by 45 over 60, you get 6 whole number 2 over 3 kilometers per hour. So that will be the new speed. Remember, they want the exact speed. Kindly don't put your answer as a decimal because they want it in exact, meaning without any errors. Let's have a look at question number 20. The ratios of bulls to camels at Algebra Ranch at the start of the year was 3:7. After selling 20 bulls and 40 camels at the start of January, the ratio changed to 5:12. Part A, calculate the initial number of bulls and camels in the ranch. This is a simple question. You can see the ratio of bulls to camels in a ranch was 3:7. After selling 20 bulls and 40 camels at the start of February, the ratio changed to 5:12. So I'll say let the total number of animals, let the total number of animals be y. So if the total number of animals is y, then it means the bulls is 3/7y, then the camels is not 3/7, should be 3/10. The total ratio should be 10. 3/10y, then the camels is 7/10y. After selling 20 bulls, what is the remaining number of bulls? So the new remaining number of bulls will be given by, remember the ratio, this can be 3y minus 20. Then 40 camels were also sold, so the new number of camels remaining will be 7y minus 40. So they are saying the new ratio now of bulls to camel is 5:12. When I take bulls, which is 3y minus 20 over 7y minus 40, this will be equal to 5/12. I hope we are clear up to that particular step. What do we do here, ladies and gentlemen? We are going to do what is called cross multiplication. Let us cross multiply this. So when you cross multiply, we are going to get this as 12 into 3y minus 20 should be equivalent to 5 into 7y minus 40. So when you open the brackets, this will be 36y minus 12 times 20, this is 240, being equivalent to 5 times 7y, this is 35y, minus 5 times 40, this should be 200. Let's collect the like terms. So this goes there. So this will be 36y minus 35y is equals to negative 200 plus 240. So when you reach here, 36y minus 35y, this will be y is equals to negative 200 plus 240, this is 40. So y is giving us 40. Y is giving us 40. Y is giving us 40. So after getting the value of y is 40, now here we need to go and become a bit serious on it. When we go and become a bit serious on it, let's get the initial number of bulls, because the ratio was 3:7. If the total number of animals were y, meaning that to get the number of bulls, it is 3y. So this will be 3 times y, which is 40. This gives you 120 bulls. Then we can also get the number of camels. To compute the number of camels is 7y. So this is like saying 7 times 40, which is 280 camels. 280 camels. So that is the initial number of bulls and camels in the ranch. Let's make progress to part B. From February to June, the number of bulls in the ranch increased in the ratio 8:5, while that of camels decreased by 15% due to the camel disease outbreak. Calculate the new ratio of camels to bulls. A very simple one once again. Remember, they are saying from February to June. So they are saying after selling 20 bulls and 50 camels at the start of February, meaning let's get the number of camels and bulls remaining. In the month of February, how many bulls were remaining? In the month of January or February, we had from the total of 120 bulls, they sold 20 bulls. So this will be 120, you less 20, meaning they were left with 100 bulls. Let's also compute the number of camels that remained. The number of camels from the total of 280, you are being told here that 40 camels were also sold at the start of February. So when you less 40, you are going to get 240 camels. 240 camels. Then now they are saying that from February to June, then the number of bulls in the ranch increased in the ratio 8:5. So let me get the new number of bulls. To get the new number of bulls, because they increase in the ratio of 8:5, so it will be now 8/5 times 100. This will become, when you take 8/5, you multiply by 100, this will be 160 bulls. This will be 160 bulls, while that of camels decreased by 15%. So the new number of camels, if they decreased by 15%, so from 100 you less 15, this is 85. So this will be 85/100 times the original number of camels at February, which was to 40. This evaluates to, when you take 85 over 100 multiplied by multiply this by 240, you get 204 camels. 204 camels. Now they want the new ratio of camels to bulls. So when they want the ratio of camels to bulls, we're going to take 204 is to 160, which is equivalent to, when you have 204 over 160, ladies and gentlemen, we are going to get 51 is to 40. The ratio is 51 is to 40. That is how you compute that particular case. 51 is to 40. Part C. The ranch management decided to sell off all the livestock at the end of June to a slaughterhouse that paid them a total of 78,474,000 from the whole stock. Given that they sold each camel at 3,115 shillings, sorry, 315,000 shillings, calculate the average amount of money that Al Julmera received from the sale of each bull. So when I take, they are talking about at the end of June. How many animals were there at the end of June? We had 160 bulls and 204 camels. They sold each camel at 315,000. So when I take 315,000, I multiply by the number of camels which were there by the end of June. There were 204 camels, plus the total cost for the bulls. How many bulls were there? They had 160 bulls, but I don't know the price of each bull. Let the price of each bull be K. So this should give me a total of 78,474,000. So when you take 315,000, you multiply by 204. This is 64,260,000 is equal plus 160K is equals to 78,474,000. Let us collect the like terms. So this will be 160K is equals to 78,740,000. You less 64,260,000. So this will be 160K being equivalent to, when you subtract this, you are going to get 14,480,000. So to get the value of K, to get now the value of K here, we are going to take the 14,480,000 divided by 160. So K will be equivalent to 90,500. 90,500. Remember, they want the average amount of money that Al Julmera received from the sale of each bull. So it is 90,500 shillings. That is the average from the sale of each bull. Have I computed it the right way? Remember, I had, let me confirm, 204 times 315. When I subtracted, I got, what did I get? When I took 78,000, let me confirm, 78,474,000. Then I subtracted 64,260,000. I got 14,000,000 I messed here. This should give you 14,214,000. This should give you 14,214,000 here. 14,214,000. So here, this should be 14,214,000. Let us see. 214,000. So when you divide, what are we going to get? I think I just messed slightly there, but it's something correctable. So when you divide this by 160, you get 88, 83, 7.50. So they want the average. So our answer is going to be 88,837.50. That is how you solve that particular question. Let's go to question number 21, ladies and gentlemen. We are progressing very, very well. I hope you are learning. We are being told that the figure below shows a circle with a center O, in which point A, B, C, D, E, F lie on the circumference, and the chord AC intersects with the tangent externally at D. Given that the angle AFC is 49 degrees, and the line ED, let's see, ED and CD are 8.1 and 5.7 respectively. Calculate the sizes of the angle AEC. AEC, this angle. Now, look at this. If this angle is 49, this angle is also going to be 49. The reason is angles subtended by the same chord. ABC, let me see. ABC, where is the B? ABC. ABC is this particular angle here. With that angle, we need to be very, very keen. First of all, allow I complete this cyclic quadrilateral. I can complete it that way. So let us look at it keenly. If this is 49, this one also ought to be 49 because of the base angles, because this is the center. This is also 49. And if this 49 plus 49 is 98, 180, you less 98, you'll get this as 82. 82. If that is 82, we can also be able to get this, because it will be now 180 minus 82 to give you 98. And if this angle is 98, 180 minus 98 is 82 divided by 2, 41. So this is 41. This one also here is 41. So if this is 98 vertically opposite, meaning this one is also 98. So this is 41. 41. So I'm still trying to figure it out. So the moment we have this, what are we supposed to do? So in this case, when they say this angle, we are going to say that this is 49 degrees. The reason we are going to give is that angles subtended by the same chord are always equal. Is it the same case? Yes, because AEC. I hope that one is very, very clear, ladies and gentlemen. Now, when we look at this ABCE, let's look at ABCE. ABCE is a complete cyclic quadrilateral. It's a complete cyclic quadrilateral. So if ABC is a cyclic quadrilateral, then this angle should opposite angles of a cyclic quadrilateral add up to 180 degrees. So this angle will be given by 180 minus 49. When you take 180 minus 49, this is 131 degrees. Then we are going to say here that opposite angles of a cyclic quadrilateral are supplementary, or they add up to 180 degrees. The length in centimeters to 1 dp of the chord AC, the length of the chord AC. The length of the chord AC here, we are going to apply a principle that says ED squared is equal to AD times CD. AD times CD. So ED squared, what is our ED? The length ED is 8.1 squared. So this will be 8.1 squared is equals to AD. If I call this one to be K, from A to C is K. AD is K plus 5.7. I'll talk about K plus 5.7 times CD, which is 5.7. So this will be, when you have 8.1 squared, this is 65.61 is equals to 5.7K plus 5.7 times 5.7, you get 32.49. So this means 5.7K is equal to 65.61 minus 32.49. So this is a 5.7K will be equivalent to, when you subtract this is 33.12. When you divide through by 5.7, you will get K being equals to 5.81. But now they want it to 1 dp. So the length AC will be 5.8 centimeters. 5.8 centimeters. The radius to the nearest millimeter of the circle. How are we going to get the radius of this circle, ladies and gentlemen? The radius of this circle is going to be very simple. Because I have now the length of AC, this length of AC corresponds with this angle E. So I'll say E over sine AC. I'll say here E. I'll talk about AC over sine E should be equals to 2R. So AC here is 5.8. This is to the nearest, now they're talking about to the nearest millimeters. So we'll talk about, I can get this as AC is 5.8 over sine E, and the angle there at E is 49, should be equals to 2R. So this will be 5.8 divided by sine 49, you get this as 7.69685. 7.685 is equals to 2R. Therefore, our R will be 7.8.685 divided by 2, meaning that our R 7.685, when you divide this by 2, you're going to get 3.8. We are having we are having, let me see. This case here now we are having 3.8425 centimeters to the nearest millimeter. You know that Kenya has dug little dams containing magics. You know that 1 centimeter is equals to 10 millimeters. What about this? So it will be, what about 3.8425? You cross multiply. This will be 3.8425 times 10. This becomes 38.425 millimeters. So the moment you have this as your millimeters now, they want your answer now to the nearest millimeter, meaning to the nearest whole number, to the nearest whole number. Yes, so to the nearest whole number here, the answer is going to be 38 millimeters. 38 millimeters. I hope that is very clear, ladies and gentlemen. I hope that is clear. Let's go to question number 22. We are at question number 22 now. We've been told in question number 22 that the figure below shows a schematic diagram of cross-sectional area of a cathedral door designed by Canaan Carpenters and Fabricators Limited, comprising of a rectangular part ABCD joined by an arc AFD, which does not form part of a semicircle, joined by just an arc AFD, which does not form part of the semicircle, and F being the farthest point from the line AD, and also that E is the midpoint of AD. I hope you can relate the language in use there. Besides the diagram, calculates the cross-sectional area of the diagram. We need to calculate the cross-sectional area of the diagram. Now, when you look at it, when you look at this first, the first thing we're going to do is the diagram is made up of two parts, the rectangular part and the semicircular part. Allow I calculate first the area of the rectangle. I'll start by getting the area of ABCD, which is a rectangle. It's normally length times the width. So our length here is 5 and the width is 8. So this will be 5 multiplied by 8 to give you 40 square centimeters. After this, we are also going to calculate now the area of this semicircular part. But now with this semicircular part, we literally need to be very, very keen. So first, we are going to calculate the radius of the semicircle forming the arc AFD. We need to get the radius here, and we need to be very, very categorical. To get the radius, in this case, we all know that. Let me explain how we are going to get this. So, to get the radius of this semicircle, we need, remember the question is 5 marks. To get the radius of this semicircle, let's assume this is our semicircle here. That's our semicircle. Then, with this as our semicircle, let's say we have a chord here. That's our chord. And if this is our chord, let's call it AB. Then I have this distance here. If this is 2.5, 2.5. how are we going to get this particular area? We need to get the radius, to locate the radius here. So with this one here, allow I extend it this way. Let me drop this one this way for better understanding. If this is our F, this is our E, allow I call maybe this one here our G. Then applying the property of intersecting chords for chords intersecting internally inside a circle, I expect AE times EB to be equal to FE times EG. So this means when I take AE, our AE is 2.5 times EB, which is also 2.5. This will be equal to FE. Our FE is 1, so that is 1 multiplied by EG, which I don't know. I can just maintain the value EG here. So 2.5 times 2.5, you are going to get this as 6.25. 6.25 is equals to 1 times EG. This is just EG. Now, remember, FE divides the chord A. Sorry, how did I write this as B? This could have been D. Let me just change this one to D to match exactly what is in my diagram. This was AD. So AE times ED should be equal to that, yes. The chord AD has been divided by has a perpendicular bisector FE. And the perpendicular bisector of any chord passes through the center of a circle. Any line passing through the center of the circle joining two ends of the circle is called a diameter. So in this case, the diameter of our circle, ladies and gentlemen, is 6.25. Thus, the radius is going to be 6.25 divided by 2. So our radius will be, when you divide this by 2, 3.125. That is the radius of our circle. I hope up to that particular point, 3.625, we've understood one another. Up to that particular point, we've understood exactly one another. That is my hope, that we've understood one another. Now, after that, we can now calculate now the area of the semicircle. Now area, the area of this semicircle now, after getting the radius, remember now we have the radius obtained here, we are now going to calculate the area of this semicircle. So with this, first we have to calculate the angle that's being subtended at the center of this chord. So to get the angle subtended at the center of a chord, what we are going to do, because we know that the radius is 3.125, I'm going to assume this is my center. I'll join this way, I'll join this way. So even before we go and get the area, there is something I want we agree on here. So I'll have a figure like this. I'll have a figure like this. I'll have a figure like this, such that this is 2.5, this is 90 degrees. But now remember, this from A to the center is the radius, 3.125. 3.125. I want to get this angle formed here. So my interest is to get this particular angle, the angle at the center. So this is opposite hypotenuse. I'll use sine. So I'll say sine theta is equal to the opposite, which is 2.5 over hypotenuse, 3.125. Then my theta will be, apologies there. Our theta is now going to be, let me see. I don't know, as my laptop has misbehaved a bit. Let me fix that. I hope we are together. I hope we are together. Okay. So when we are here, now to get my theta, I'm going to get the sine inverse of 2.5 over 3.125. So my theta will give me, when you get the sine inverse of 2.5 over 3.125, you get your angle as 53.13. 53.13 degrees. Remember, I've completed this circle this way. I've assumed this circle is completing this way, and this is now the center. And when I join like this, the angle subtended here is that one, 53.13. Now I want to get the area. If I have the sector A, if this is O, if I have the sector OAFD, I want to get the area of that semicircular part. That is the area of the segment. I'll have to get the area of the triangle minus the area of the sector. Let me get the area of the triangle. Area of the triangle will be given by the formula I have AB sine theta, because we have the angle in between. So we are going to apply the formula that I have AB sine theta. So in this case, we are going to talk about I have AB sine theta. So the area of this triangle will be given by a half times A and B are the radius. So this is 3.125 squared sine 53.13. So this angle is going to give us 0.5 times 3.125 squared sine 53.13. This will give you 3.906 square centimeters. That is the area of that triangle AOD. After getting the area of this triangle, let's compute the area of the sector. Allow I compute the area of the sector. Let me compute the area of the sector. Now, area of the sector is given by theta. Area of the sector is given by theta over 360 pi r squared. So this will give us, our theta here is 53.13 all over 360 multiplied by pi 22 over 7 by the radius 3.125 squared. So this will give you, when you take 53.13 over 360 multiplied by 22 over 7 by 3.125 squared, this gives you 4.53 square centimeters. Now we can get the area of this of the sector. I can now get area of the segment, sorry. Area of segment A FD. To get that area, I'll take the area of the sector, 4.53, minus the area of the triangle. The area of the triangle I have 3.906. 3.906. When you subtract the two, 4.53 minus 3.906, this gives you 0.624 square centimeters as the area of that sector. Now, remember the rule was to get the total. So now to get the total area, I'll take the area of the rectangle. The area of the rectangle was 40. So in this case, I'll take my 40 plus 0.624. This is a 40.624 square centimeters. That is the area of this solid. Oh, sorry, that is the cross-sectional area of this figure. That is the cross-sectional area of that particular figure. I hope we are together up to this particular case. Now here I think there is a small thing. When I got EG was not the diameter. I was supposed to add 1 to the EG because the diameter is FG. So the real diameter value here is 6.25 plus 1. I had that omission. Apologies there. Let me just update it. Because I've seen, yes, the diameter should have been 6.25, but now plus 1. This could have made it 7.25. Let's have it here. Which also will now change our radius. Let us see. Because the radius now will be given by 7.25 divided by 2. So our radius here should be, when you take 7.25 and you divide by 2, you get 3.625. 3.625 centimeters as the radius. So this should be 3.6, not 0.1. 3.625. Let us just have these values updated. This should be 3.625. This should be 3.625. I think it's going to cause some minor changes here, but it's very important we update. 3.625. It can also even change this angle, I think. So this is now 3.625. So when you get the sine inverse, the sine inverse of 2.5 over 3.625, you'll get your angle as you'll get this angle as 43.6 degrees. The moment we have this angle here as 43.6 degrees, ladies and gentlemen, this angle here is 43.6 degrees. What are we going to do next? If that angle is 43.6, then the whole angle, let me say angle now AOD will be 43.6 times 2. 43.6 you multiply by 2, you get 87.2. Once you have that angle now as 87.2, so area of a triangle will be a half times 3.625 sine. This one I'm seeing it changing even these values here. Let us see. So the sine of sine 87.2, 3.626. So when I have 0.5 times 3.625 squared sine 87.2, I'll get 6.562 as the area of the triangle. Then when it comes to the area of the sector, remember our angle here is different. Our angle, we found it as let me have this one also updated. Our angle here is 87.2. So this is 87.2 over this times 6.3.625. So this will be 87.2 over 360 times 22 over 7 times 3.625 squared. This gives you 10 square centimeters. Then now to get the area of this segment, you take the area of the sector minus the area of you should take the area of the sector minus the area of the triangle. The area of the sector now we found as 10. Remember that. I found the area of my sector. The area of my sector here is 10 minus the area of the triangle, which is 6.652. When you take 10 minus 6.562, this is 3.435 square centimeters. And once you have that, now the total cross-sectional area, ladies and gentlemen, will now be given by 40, which is the area of this triangle, so the area of the rectangle, plus the area of that segment, which is 3.435. So this becomes 43.435 square centimeters. A very good question. It had its own trick. I hope learners you've understood. Part B, given that the length AB is the actual door, the length AB, which is 8 centimeters, is the actual door, and the actual door is 40 millimeters thick, calculate to the nearest cubic centimeters the volume of the door. Calculate the volume of the door. So when you are told now to calculate the volume of this door, what are we going to get? In order to get the volume of this door, we are now going to say that I want to calculate now the volume of the door. Volume of this door, volume will be given by, first of all, I want us to relate this. Given that the length of the actual door is 3.2 meters. So that 3.2 meters is representing 8. I want us to get that way. In fact, even before I write the volume, I have to say, I want to get the actual measurements. So, we will say we are going to say here that that if 3.2 meters is being represented by 8, if 3.2 meters is being represented by 8, what about the width, which is 5? What is the actual width? So here I want the actual width. I want to compute the actual width. So to compute the actual width, we are going to have 3.2 times 5 divided by 8, which will give me, when I take 3.2 times 5, then I divide by 8, the actual width becomes 2 meters. So to get now the volume, I'll take the actual length multiplied by the actual width multiplied by the thickness. This 40, remember from the acronym that Kenya has dug many dams containing magics. If you want to know the relationship, is that 1 meter is equals to 1,000 millimeters. So this 40, I love this as 40 over 1,000. I want to convert it to meters. So when you execute this will be 3.2 times 2 times 40 over 1,000. This is 0.256. 0.256 cubic meters. But now because they want it to the nearest cubic centimeters, what are we going to do? To the nearest cubic centimeters. To the nearest cubic centimeters, we are going to have, when you convert it to the nearest cubic centimeters, we should be able to get let's have a look at it again. Remember that the actual dou is 3.2, so that just a minute. The best approach we can even apply in this part B, let me give you the most simplest approach. The most simplest approach here, ladies and gentlemen, is this one. Because one thing we have to note is that, let me just a minute. Let's get the simplest approach to this problem here. First of all, we are being told that there is a slight difference here, in that the actual dou measures different from what is on paper, because the actual dou is 3.2 meters, which is at 320 centimeters, but it's being represented by 8 centimeters on a piece of paper. So let me get the scale factor. If I want us to note that, apologies again, my laptop tends to misbehave. Just give me a minute. So if 8 centimeters represent 3.2 meters, which is a 320 centimeters, let's get the scale factor, the linear scale factor. The linear scale factor, when I take the height of the image, the height of the actual object, which is 320, over the height of the diagram drawn, ladies and gentlemen, we are going to get this as, we are going to get this as 320 over 8. So the scale factor here is 40. That is the linear scale factor. If this is now the linear scale factor, we can get the area scale factor. The area scale factor is simply the square of the linear scale factor, so it's 40 squared, which is 1600. Then if this is it, let's now get the volume. To get the actual volume, I'll take to get now the actual volume, I'll take the measure we had gotten on top there, which is we had gotten 43, that was centimeters. Yes, this one was also in centimeters. 43.435. We are going to have 43.435 times our scale factor, which is 1600 now, but now times the actual thickness, which is 40 millimeters. In terms of centimeters, this is 4 times 4, because 40 millimeters is just like saying 4. And when you multiply this, 43.325 times 1600 times 4, let me just confirm, this is 277,280 cubic centimeters. That's how you sort that part. Part C of the very paper. Calculate with the nearest 100 shillings the price in which Canaan carpenters will sell the door, making at least a 30% profit, given that 1 cubic centimeter of timber used cost this amount, while the labor and other costs of production is always 20% the cost of the timber. Let me get the cost of the timber. The cost of the timber here will be 587,200 multiplied now by the, we need to multiply this now by the actual volume. We need to multiply this. You will multiply this by what we got here. We had 277,280, but because this was cubic centimeters, to convert it to cubic meters, you divide by 1,000,000. We are dividing it by 1,000,000 to convert it there. So when I divide it by 1,000,000, then I multiply this by 57. This will be 587,200. What did I write here? This should have been 587,200. 587,200 here. This one here is 587,200. We are having 587,200. So this is 16,000. Is it not 16,000, but yes, 160. Let me see. This is 162,000. This is amounting to 162,818. Let me see. Mm-hmm. 162,000. 162,818.816. That is just the cost of the timber. that is just the cost of the timber. Mm-hmm. 0.816. So the moment you have this as the cost of the timber, we are being told that the labor and other cost is 20% of the cost. So let us see the labor. The labor cost here is 20%, 20 over 100, 20 over 100 multiplied by, my laptop is a bit lagging. So when you look at this question, we are being told that the labor cost and the labor and other cost of production is always 20% the cost price. So we need to compute 20%. 20% is 20 over 100. Multiply this by this amount, 162,818.816. So you find that the labor cost, when you take 20 over 100 times 162,818.816, you get 32,000. You get this as 32,563.7632. That is the labor cost. Now, if that is our labor cost, ladies and gentlemen, what do you need to understand? If that is our labor cost, you need to understand now, what is the question asking? We need to calculate the nearest centimeter to the nearest 100 shillings, the price at which Canaan carpenters should sell the door to make at least a 30% profit. So let's get the total cost. The total cost, we take the cost of the timber, which is 162,818.816 plus 32,563.7632. When you add this, you are going to get a total cost of, let us add this, 162,818.816. You get 195,382.5792. So this cost is equivalent to 100%. So to get the selling price, we get now 120% of this. So this will be 120 over 100. So that will make a profit times 195,382.5792. So when you do this multiplication, this becomes 234,459.095. But not because they want it to the nearest 100 shillings. So this will be 234. These ones tens 100. This will be 234,500 Kenyan shillings. 234,500 Kenyan shillings. Let's have a look at question number 23. The central business district within a city is 36 kilometers away on a bearing of south 43 degrees east from the estate. from the estate X. Estates W and Y are 45 kilometers to the west and 24 kilometers to the east of CBDA, respectively, while estate Z is on a bearing of 149 degrees and 12 kilometers from estate W. Using a scale of 1:500,000, draw a scale diagram representing the information above. 4 marks. So we are going to start by analyzing it this way. So in this case, because we are told that the central business district A within a city campus is 36 kilometers away on a bearing of south, 43 degrees east from estate X. So we are going to start by locating estate X. So let's assume I want to locate estate X first. This is estate X. So this one A is south 43 degrees east. So it is from south 43 degrees towards the eastern side. It is that way. So this is the angle 43 degrees. So you make sure that the distance is 36 kilometers. This 36 kilometers, you change it to meters, to centimeters, by taking 36 times 100,000. Then you divide this by 500,000. So this is like saying 7.2 centimeters. 7.2 centimeters. So you measure 7.2 centimeters. Then where you reach here, this becomes your point A. This becomes your point A. I'm just giving a sketch. This becomes our point A. Then estate W and Y are to the west, are 45 degrees to the west, 45 kilometers sorry to the west, and 42 kilometers to the east of A. So if this is my A, we have Y, which is 45 kilometers. So 45, you change it to centimeters by taking 45. You multiply by 100,000, then you divide by 500,000. This becomes 9. So if it becomes 9, so to the west is this way, this particular direction. So up to maybe, let's say this particular point. So this is W. This is 9 centimeters. Then they are saying east, Y is 24 kilometers to the east of A. So 24 kilometers, in terms of centimeters, you take 24. 24 you multiply by 100,000. You divide this by 500,000. This is 4.8. So going to the eastern side is 4.8 centimeters. This is 4.8 centimeters. Then where you reach here, this is our Y. So that is what we are having. Then we have Z, which is on a bearing of 149 kilometers from W. 149 kilometers from W. On a bearing of 149 should be 149 degrees. So a bearing of 149 degrees from W, and the distance is 12 kilometers. So 12 kilometers, you take 12 times 100,000. This becomes 1,200,000 centimeters. Divide by 500,000. This becomes 2.4 centimeters. So it comes this way. That is our 2.4 centimeters. And this point here is now the point Z. So this is our Z, and this is 2.4 centimeters, and this angle here is 149 degrees. You make sure it's 149 degrees. After this, we have your 4 marks. Then now you go state the compass bearing of X from Z. x from z, you join x to z. Let's join x to z, dear learners. So x to z is here. So they want the compass bearing of x from z. So from z here, this angle here, you'll take the compass bearing. Compass bearing, I hope you know how to write, maybe north a certain degrees to the east and so on. That one you can be able to give. I'm not able to provide because mine is a sketch. These cities, counties, borders are defined by straight roads joining W to X to Y to Z, W to X to Y to Z, then to W. Let's see. W to X, we have W to X, X to Y. Then after going to Y, what are they saying? W to X to Y to Z, then to W. Let's join from Y. Another border here is from Y now to W. Then from W back to Z. From W back to Z. I hope you can now see the border. Then calculate the area to the nearest sector of the city. Let us calculate this area. When you look at this border and you are told to calculate its area, what are we going to do? Let's see how we are going to calculate this area. There are several methods we are going to use. There are several methods. I can decide to calculate the area of here I have two triangles. I can divide these to two triangles. Triangle X Z W X W Z. We have this one. Let me calculate the area of that. And how do you get the area of this figure? To get the area of this figure here, learners, what we need to do, if we had the measure for xz, but I can still use what is called, let me see, we have a side that we have to get, no. So here I'll take the area of xwz. So in this case, I'll have to take the area of xwz plus the area of, we have to add it to the area of xyz. So the two areas, now you change to hectares and get it. Again, there are measurements I need to take. On my end, I will not be able to do it because mine is a sketch. Part D, estimate the population of this country given that the approximated population per person is, per persons occupy approximately 260 persons occupy 1 hectare. So I'll say if 1 hectare is equals to 260 persons, what about the number of hectares we got in part C? What about the answer we got in part C? Then you cross multiply, you'll be getting your answer. You will be getting your answer. Question number 24. The figure below shows the graphs of curves A and B. You can see the two curves. Curve A is curving upwards, curve B is curving downwards. The question that follows says, fill in the values of y ordinates corresponding to the given x ordinates for the curves A and B in the table below. We have the x, when x is 2, curve A is 6.6, curve B is 8.2. Let's confirm. 6, this is 6.6, then the other one is 8.2. That's very true. When x is 3, curve A reads, let me see, when x is 3, curve A is reading 9, curve A is reading 9.4. 9.4, so this will be 9.4 here. That is the one for curve A at 3. Let me see, at 3, curve A is reading 9.4. Here we need to be very keen. Curve A is reading 9.4. This is no curve A. Curve A should be reading 6.4. Not, yes, it should be at 6.4. Yes, 6.4. This one is at 6.4. When x is 4, curve B is reading. When x is 4 here, curve B is reading 6.3. 6.3. That is curve B. Then when x is 5, curve B is the one that curve B should be reading. This case, this is 10.2.4.6, 10.6. Let me confirm this one here. I think this one I've written wrongly. This one is for A, not for the required B. Let me have it changed. When x is reading 4, the corresponding value at curve B is, when x is 4, this is 4, the corresponding value at B is 10.2, should be at 10.2. So this one should be 10.2. When x is 6, curve A is reading. When x is 6 here, curve A is reading 6.4. When x is 7, curve B should be reading. When x is 7, curve B is reading, that is 11. That is 11. Curve B should be reading 11. When x is 8, curve B should read. When x is 8, curve B should read, this is 10.9. 10.9. Is it 10? Yes, 10.9. That way. When x is 9, curve A should read. When x is 9, curve A should read, this is 7.2. 7.2 here. 7.2. Finally, when x is 11, curve A should read. When x is 11 here, curve A is reading 9.4. 9. Sorry, curve A, they want curve A. Curve A should be reading, this is 8.3. 8.3. Curve A should be reading 8.3. So the moment we've gotten those particular values, ladies and gentlemen, we can now make some progress. Using the trapezium rule with 4 strips, estimate the area bounded by the curves A and B between x equals to 2 and x is equals to 10. So first of all, I can get this, the value of h, which is usually given by xn. H will be given by xn minus x naught divided by the number of strips. So xn is 10 minus x naught 2 divided by the number of strips 4. This is 8 minus over 4, which is 2. So our height here is 2. So when you are told between x is equal to 2 to 4, this means we are going to make at x table. X will move from 2. The interval is 2, so 2 plus 2, that goes to 4, then 6, then 8, then finally 10. So in this case, I want just to have these ones here combined. This is my mini table. So in this case, this is what we are going to do. Let's take the y value of A, then the y value of B, then here the difference ya minus yb, but we take the absolute values. So when x is 2, we have 6.6, 8.2, 6.6, 8.2, 6.6, 8.2. When y is 4, 6.3, 10.2, 6.3, then this is 10.2. When x is 6, 6.4, 10.9, 6.4, then 10.9. When x is 8, we can see 6.8, 10.9, 6.8, 10.9, 6.8 here, then 10.9. Finally, when x is 10, 7.7, 10.2, 7.7, 10.2. After getting that, now the area bounded by the two curves is the difference between the two. So we are now going to get the absolute values. So absolute values, we're going to take 6.6 minus 8.2, then you differentiate, you take the absolute value as 1.6. We have 6.3 minus 10.2. So 6.3 minus 10.2, you get 3.9 absolute, 3.9. Then 6.4 minus 10.9, this one gives you absolute value of 4.5. 6.8 minus 10.9, this is 4.1. 7.7 minus 10.2, this is 2.5. After getting these as the absolute values, now we are going to apply the formula of calculating area using the trapezium method. We are all aware that area is given by a half h into y naught plus yn plus 2 into y1 plus y2 all the way. So this will be now a half times h, which we found as 2, into the end values of the y, that is 1.6, 1.6 plus 2.5, then plus 2 into the middle y values, that is 3.9 plus 4.5 plus 4.1, that way. So this will be a half times 2, that is 1, into 1.6 plus 2.5, you get 4.1. So this will be 4.1 plus 3.9 plus 4.5 plus 4.1. This is 12.5. You multiply by 2, this is 25. 25 plus 4.1, this is 29.1 square units. So that is the area between the two using the trapezium method, 29.2. I hope that is very clear. Let's use now the mid-ordinate rule with 4 strips to estimate the area bounded by the curves A and B between x is equals to 3 to x is equals to 11. Here now they have extended x is equals to 3 to x is equals to 11. First of all, I'm going to get my h. My h is given by xn, which is 11, minus x naught, which is 3, divided by the number of strips 4. So this will be, when you take 11 minus 3, 11 minus 3, that is 8, divided by 4. So our h value here is 2. So let us see. Let us have a table of xy values. We are going to have a table. We are going to have a table here. So the first value of x, from 3 we're going to go to 11, but with 4 strips. Let's go to the main table. 3 to 11 with 4 strips. 3, this is 1, 2, 3, 4. So we are going to use 4, 6, 8 and 10. 4, 6, 8 and 10. Let us see. This will now be so this will be x 4, 6, 8, 10. 4, 6, 8, 10. 4. We will have here 4, 6, 8, 10. So let us rule that way. We're going to have the y value of A, the y value of B, then the difference, y value of A minus the y value of B, then we get its absolute value. Pay much attention as we evaluate this. So when x is 4, from the table, we have 6.3, 10.2. 6.3, 10.2. 6.3, 10.2. When x is 6, 6.4, 10.9. 6.4, 10.9. Then when x is 8, 6.8, 6.8, 10.9. 6.8, 10.9. Then when x is 10, where did I begin from? Yes, 6.8. When x is 10, that is 7.7, 10.2. 7.7, 10.2. So this will be 7.7, 10.2. Let's get the absolute differences. So 6.3 minus 10.2, this is 3.9. We just pick the absolute value. 6.4 minus 10.9, this is 4.5. 6.8 minus 10.9, this is 4.1. Then 7.7 minus 10.2, this is 2.5. Then now, after we have our table, we are now going to compute our area, dear learners. we do say that area is equals to h into y1 plus y2 plus y3 maybe plus y4. So when you substitute, our h here is 2, so 2 into 3.9 plus 4.5 plus 4.1 plus 2.5. So this will be 2 into, let us add this, 3.9 plus 4.5 plus 4.1 plus 2.5. This is 15. When you multiply 15 by 2, this is 30 square units. So the area using the mid-ordinate rule is 30 square units. That is how you should have done this particular paper and gotten all your solutions correct. Thank you for watching. Don't forget to subscribe, like and share this video with your other friends. For more information, you can reach out through the number 07 41 30 43 11. See you in our next episode.